V2 minus U2. Now I will divide the first equation to the second equation, this equation to this equation. So if I divide, I have to divide both sides. What will happen to M1 and M2? So what will be U1 squared minus V1 squared over U1 minus V1? Minus or plus? Plus, because you have minus here and minus here. A minus B times A plus B over A minus B. A minus B cancels out, so what do I get? U1 plus V1 equal to what? V2. U2 plus V2. And this will be my second simultaneous equation. So instead of working with this, I will work with this and this. So I will work with this equation, which is linear momentum, and this equation, which is the equivalent to this one. So what it's telling me is that if you added the velocity of the first object will be equal to the velocity of the two objects before and after.
Irrelevant of the mass. The mass doesn't matter.
Irrelevant to the mass. The mass I cancel out with this mass and mass. So it's better to use that equation than the other one. Example. Let's do this example, the example that I was doing in class. So, let's do the following example. Just to prove this. This is the example. Imagine that I give this mass of the object. So, M1 is equal to M2, which is equal to 0.5 kilogram. This is 0.5 kilogram. V1 or U1 is 3 meters per second. U2 is 0. Find V1 and V1, V2. In other words, I will solve it. But without solving, if you know that the two masses are identical, I explicitly state that the collision is elastic. What will be V1? Look, what will be V1? This is V1 after. What is V1? 0. Everybody can see that. So I will solve it. But I am showing what will be the answer. Anybody, don't tell me what I have to do that. I want to prove it. What is the velocity V1? So I give V1, which is 3 meters per second. This is 0. They have identical masses. When these collide with this elastically, what will be V1 conceptually? Tell me. 0. How much will be V2? 3 meters per second. For the kinetic energy to conserve, I have to get this 0 and this, how much? 3. This is what I want to prove using the simultaneous equation. Let's start. The first one, you will write when you have elastic collision, I explicitly stated, you have to say, I have to work with two equations. What two equations? This and this, but this will be this one, which I think that you have, I don't know if you have in the formula, but I think that you have this formula in the equation. I don't know if you have, but check. N1, U1 plus N2, U2 equal N1, V1 plus N2, V2. This is my first equation, and my second equation will be U1 plus V1 equal to U2 plus V2. These are my simultaneous equations for elastic collision. And let's start plotting. If this is 0.5, this is 0.5, this is 0.5, and this is 0.5, what will happen? So I have U1 plus U2 equal V1 plus V2. On the other side, I have U1 plus V1 equal U2 plus V2. U1 is how much? 3. I am in my first equation. You need to work together with the two equations. It's called simultaneous equation. So what is U2? 0. Equal. What is V1?
0.
V1 is 0? We don't know. That's what we are looking for. V1 plus V2, we don't know. On the second equation, U1, how much? What is V1? We don't know. Equal U2
0.
and plus V2. Is that right? Since I have two unknowns, I have to solve the system of equations.